So I'm glad to present here my study data, and I would talk about local field potentials and a periodic signal and how it affects our data. So one moment, I just check how can I, okay, so yeah. I study Parkinson's disease and basal ganglia activity, and Parkinson's disease is a hyperkinetic movement disorder that is caused by dopamine deficiency and subsequent basal ganglia dysfunction. And deep brain stimulation is a procedure that is proved to be effective to treat motor signs of PD. And the target for DBS is not always, but often the subthalamic nucleus. Neurosurgeons commonly use micro and macroelectrode recordings to define the borders of the subthalamic nucleus during the surgery. And these recordings provide very important data about neuronal activity in the affected structures in Parkinsonian patients. The first model of basal ganglion network was proposed about 30 years ago by Albin and DeLong, and it states that imbalance between a direct and indirect pathway may prevent normal movement. But current model of Parkinsonism pays specific attention to the patterns of neuronal activity. And they say that extensive synchronization in several frequency bands lead to the emergence of pathological oscillation in the basal ganglia structures. And here you can see the picture from the review of Peter Brown about oscillations in basal ganglia. Peter Brown states that lower frequency oscillations in theta, alpha, and beta range are antikinetic, while higher frequency gamma oscillations are prokinetic and facilitate the movement. So how can we study these oscillations? Local field potentials are commonly used as it represent populational neuronal activity, and we can apply fast Fourier transform to plot the power spectral density, and the oscillations are shown as a peaks on this spectra, and the amplitude of these peaks correspond to the power of these oscillations. However, aside from periodic oscillatory components, there is also aperiodic activity that is often referred to as noise. It is easily seen when we plot the power spectral density in a log-log scale. But these aperiodic features of LFP signals are generally ignored because it's difficult to interpret them. But recently, Richard Gao and colleagues proposed that this aperiodic component may provide some valuable information about the state of populational neuronal activity. They suggested that this slope in the spectra may reflect the ratio between excitatory and inhibitory currents in the site of recordings. They modeled LFP signal as a linear sum of inputs from excitatory and inhibitory neuronal populations. They derive inhibitory input from the current from GABA A receptor that is much slower than AMPA receptor that was used to model excitatory inputs. So they state that a periodic slope of LFP in their model may reflect the balance between these inputs and change with excitation and inhibition currents. So we decided to test this hypothesis using LFP recordings performed during DBS surgeries. It is challenging to compare the LFP spectra recorded in different patients and even in various recording sites. So we search for a task that allows us to compare LFP recorded in short period of time in the same site. We thought that if the slope indicates a shift from excitation to inhibition, we would see the changes in the slope when switching from rest to moving condition. So we collected the data in 2017, 2018 in Burdenko Center for Neurosurgery during 22 DBS surgeries in Parkinsonian patients in the subthalamic nucleus. And during recording, patients were asked to contract the fist and move foot on the contralateral side of the body. There were in total 116 LFP recordings that contain rest condition and fist contraction. And 48 recordings from this set was also containing leg task condition. Here you can see the steps of analysis, and we segmented our LFP recordings at rest and during hand and leg movement and analyzed them separately. We plot power spectral density in alpha, low beta, high beta, and gamma bands, and use two different approaches to estimate power oscillation in given bands. First, using conventional approach, we estimated power of oscillations using mean value of power spectral density in the given frequencies. And then we used the novel approach when we extract this aperiodic signal from the spectra in log-log scale, and then account for oscillation based on the amplitude of peaks after the extraction of this slope. And in some cases, there were no oscillatory peaks in a band after this procedure. So here are the data that was obtained using two methods. We compared power, and you see on the top the data using a conventional approach, and on the bottom there is the data using novel approach accounting for aperiodic component. And we see that conventional approach gives us a very significant increase in gamma oscillations, while accounting for the slope, we see a very significant decrease in the slope component, but no change in gamma oscillation score. Also, when analyzing leg movement task, we see also increase in low beta range for both methods, and p-values are not similar but comparable for these methods. So here are group spectra for conventional approach, and you see a clear increase in low beta and gamma range. And on the right side, there is individual data. Each point is an individual site of recordings. X-axis show value of power at rest, and y-axis show power at movement condition. And we see all the dots above the diagonal. They show increase in the power, and below the diagonal there is decreased values. So we see a significant gamma and low beta increase for these conditions. And here are the spectra that were obtained using a novel approach, and we see a clear decrease in the slope during movement, and also we see not very clear, but still increase in low beta band during movement. And here also to the right are individual data for all our data set. So if we consider classical boxes and arrow model here, we may state that changes in the pathways may be reflected in the movement state, and we expect increased inhibition toward the STN and corresponding decreased excitation from the STN to internal segment of globus pallidus. And these change when switching to the movement condition would lead to decrease in the balance between excitation and inhibition, and decrease the slope in the slope that we observed in our study. So in the right, you see the part of the picture that I have shown you earlier. And here we see prokinetic gamma oscillations that probably is not oscillatory activity, but maybe reflect the changes in the slope in aperiodic movement, in aperiodic broadband signal. So let me read the conclusion of our work. The slope of aperiodic noise in LFP spectra probably reflect the excitation inhibition balance of synaptic projections to the site of LFP recordings. At least our data confirm this hypothesis. The slope decrease in STN during movement may reflect dynamic changes in motor processing through basal ganglia structures, and probably display the shift in activity from an indirect pathway toward a direct pathway. The visible increase in LFP gamma power during movements may arise from a periodic source rather than oscillatory one. And in general, oscillations in lower frequency, like low beta band, were not affected after extraction of aperiodic slope. I would like to thank our team and say special thanks to my friend and colleague Yulia Semenova. She contributed extensively to this study and performed a lot of computations on spectral features. And thank you for your attention.
Thank you very much. Thank you very much, Elena. We do have some amazing timekeeping in this session. So time for questions. Again, I invite any of our participants. You can raise your virtual hand or use the Q&A or also use the chat to pose your questions. And I'll be able to unmute you so you have the option to ask the question in person. Also, yes, panelists, Sandeep, you have a question.
Okay, I have a very small basic doubt. That is, Elena, it was a nice presentation. And in one of your slides, you mentioned there is a shift in STN that power spectral density slope, STN slope, when we are moving from the shift from the direct to the indirect pathway. So can we also associate that particular shift in the frequency ranges, that is from the beta ranges to the gamma ranges to the pathological outcome? That maybe in case of Parkinson's disease, do we see in one of the study which I was referring, there is an increased frequency, the activity in the higher frequency ranges. Can we relate that to this experimental outcome that you were seeing, that is shift from the direct to the indirect pathway?
I think that we need to revise this data, and maybe we will see this change in the slope. And according to the proposals of the Richard Gao and team, which I'm referring to, they think that yes, of course, this shift reflect these changes, and maybe we can like estimate the pathological imbalance in the circuits using this metric. But I think that it's not very easy, as we need to estimate the slope, we need the recording of some duration. So we cannot estimate a very tightly, very short shifts in the slope now. So maybe when accounting for long periods, we don't have very short data, but we can measure some state. Yes.
Yeah, thank you.
Thank you. We do have a question in the Q&A, which is from Sanka, and they ask, gamma still seem to have a change, although not statistically significant, even when accounting for slope. Also, there has been evidence for gamma in dyskinesia, right? So how much can we attribute to the slope and how much can we attribute to gamma?
So I have shown here on the slide, it was not very, I haven't mentioned it, but you see N number for the aperiodic component method. So there is only 14 cases from 48 that were shown any gamma oscillation after extracting of this slope. So there was very few recordings that still have some gamma oscillations after extraction of the slope. Maybe in some other conditions, or maybe for the longer recordings, we will estimate these gamma oscillations and can distinguish this aperiodic slope from the gamma oscillations. In our study, there was a very few peaks in gamma range after extraction.
Thank you very much.